Hello and welcome to another video for this channel. So what we are going to talk about today in continuation of the previous session on number system is basically talking about two important part of your number system, which is factor and division equation. So these are the two main things that we are planning to cover today. Now, if you are following this channel for some time, so we know we talk about quant and quant related topics that are relevant for your MBA entrance exams in India. Also, what we primarily try to see is enable you with the concepts as well as the problems, which is relevant for that particular topic. Now, what we followed in arithmetic and algebra is typically have a concept session followed by two sessions on problem solving. In number system, we have changed the strategy a bit because of the nature of the topic. It's a vast topic in itself, and it will require series of small chunk of videos that will go in depth and explain you the concepts very well. Because that then only you will be able to gain understanding of the overall concepts rather than covering the entire thing in one session. We'll have a series of sessions where we explain the concepts, solve few of the problems just to enable you with the concepts, to make you better understand the concepts. And then we will have 2 to 3 dedicated session on problem solving of number system as a whole. That will make a lot of sense, we understand, and that's how we are going to approach. So the first session was on divisibility rules of different digits and the classification of numbers, absolutely fundamental founding stone of number system. Now in second session today, we are going to talk about these two topics, which is factors and division equation. Both are very important, and we'll see multiple questions over the past years of CAT paper has appeared from this area. So without further ado, let's get started. So when it comes to factors, what we need to understand is we primarily talk about the prime factorization. What I mean by prime factorization is basically given a number, a composite number, how you can break that number in terms of its prime factors. So let's say I have a number 12. So if I have to break it into factors and you go back to your school days kind of thing, you have done this approach. So you have divided by 2, then 6, then the lowest prime factor of 12 is 2. So you start from 2, get 6, and 2 can go further in 6. So you will get 3. Now 2 will not anymore the case. So we can write 12 as 2 into 2 into 3, right? So this is the prime factorization. Obviously, I can write 12 as 12 into 1, 6 into 2, multiple ways, but neither of 12 and 6 are prime numbers. So the idea of factor or prime factorization is breaking it into prime factors, starting from the smallest one and then go further. So this 12, I can write it as 2 square into 3, right? So this is the way you break it. So take another example. Let's say I want to break 30. So I'll do 2, 15, then 3, I'll get 5. So 30, I can write it as 2 into 3 into 5, right? So this is the way I do prime factorization. Now there are a series of concepts that needs to be understood before you solve a factorization level problem. So this is the base of how you do factorization, and based on that, there are multiple follow-up concepts that you need to understand. So the first one, if you can understand, can you tell me how many factors are for 12? So 12 has how many factors? So can I answer it with this formula? So I know if I just see 12, I know 1, 2, 3, 4, 6, and 12. These are the 6 factors of 12. By factor, I mean the numbers that can completely divide 12. So these are the 6 factors of 12. Now, if I have to do from here, I'll say 2 square and 3 to the power 1. So can I say, if I just focus on the exponent indices or the powers, then we will be able to say that is 2 plus 1. This 2 is coming from this 2. into 3 plus, sorry, into 1 plus 1. So that is, and this 1 is coming from here. Okay. So then 3 into 2, 6. So basically, to generalize this, if there is a number which you can write it as, let's say, a to the power p into b to the power q into c to the power r, then the factors of n, or instead of number, let's just write number of factors of n is p plus 1 to q plus 1 into r plus 1. So this is the first concept that we need to understand. So this is the very first concept that you need to understand. What are the number of factors of a number? So for 12, you can manually do it like this. But let's say if I give you 148, the approach is not very straightforward. Let's do it for 148 actually and see how many factors 148 has. So 148, if I do by 2, will give me 74. If I do further by 2, it will give me 37. 37 is a prime number. It cannot be broken down further. So can I write 148 is nothing but 2 square into 37, 37 to the power 1. So factors of 148 is, I'll say count of factors for 148 is 2 plus 1 to 1 plus 1. So that is 3 into 2, 6 factors that are for 148. So this is what we do, and that's how we calculate. So how we got this 2? So this 2 and this 1 coming here, and you are just adding 1 to each of the exponents of the indices. So that's how we do it. So let's take another few examples. Let's say 25. How will we do? 5, 5. So if I say 25, it's a 5 square, then the number of factors should be 2 plus 1 equal to 3. So 25 has 3 factors, 1, 5, and 25. Similarly, let's say 36. 36 is again 2, which is 18, 2, which is 9, 3, 3. So can I say 36 is basically 2 square into 3 square. So the number of factors should be 2 plus 1 into 2 plus 1, or 3 into 3, 9. Right? So 36 has 9 factors. Similarly, let's take another square. Let's say 100. So 100, I can say 2, 50, 2, 25, 5, 5. So 100, I can say as 2 square into 5 square, right? And in that, we can say the number of factor is 2 plus 1 into 2 plus 1. So 9. So 100 also has 9 factors. So you can say from here, can I then draw a conclusion that all the squares, be it 25, be it 36, be it 100, has odd number of factors, right? Apart from the squares, you take any random number. You take actually any random number. Let's say 40. 40 is not a perfect square. Now with 40, if I do by 2, you get 20, 10, 2, and 5. So 40 is 2 cubed into 5. So the number of factor is 3 plus 1 into 1 plus 1. So that is 4 into 2, 8. So apart from a square or a perfect square, every other composite number, you will be seeing that it will have a number of factors which are even in number. So this is 8. You take any composite number and try to find out the factors of those composite number, you will be able to see the number of factors are even. But only for the perfect squares, the number of factors are odd. So perfect squares will have odd number of factors. Perfect square will have odd numbers factors and vice versa. So if we say there is a number which has odd number of factors, then you can identify that the number is a perfect square. Okay, so that you can, so this is one other information you can understand. So let's say, and let's take an example to help you solve better. Let's say n is a number and n has, let's say, 7 factors. 7 factors. N is a number, n has 7 factors. Can you tell me how many factors n square will have? So what I can understand from here, n has 7 factors, then n has to be a perfect square. So 7, if I, let's say n is a to the power p into b to the power q into c to the power r. So then the number of factors, so can I say p plus 1 to q plus 1 into r plus 1 should be equal to 7. Now 7, you can typically write it as a multiplication, only 2 ways, multiplication of 2 or more number, so that is 1 into 7. Okay, so 1 into 7. So, or I can say for easy understanding, let's say 7 into 1 into 1. So if this is 1, then your q is 0. If r is 1, then your r is also 0. And p is 6. So can I say 7 is nothing but a to the power 6, which is equal to n. So that's why it has 7 factors. So basically, how am I trying to figure out if it has 7 factors? Then I'm trying to guess n is at a to the power b, b to the power q, c to the power r. That's the factorization of n. Now 7 can only be written as 1 into 7 as a multiplication, or 7 into 1 into 1. So if other q plus 1 is 1, q will be 0. R plus 1 is 1, r will be 0. Similarly, then p has to be 6. So then n becomes a to the power 6. If n is a to the power 6, your n square becomes a to the power 12. So that means n square will have 13 factors. Understood how we can approach this problem? If there is any difficulty in understanding, please drop a note in the comment section and I'll be able to explain. Let's take another type of example. Let's say n square has 15 factors. N square has 15 factors. N cube will have how many factors, right? So in that case, let's say n square has 15. N square has 15 factors. So can I say n square is a to the power p, b to the power q into c to the power r, right? So I can say p plus 1 into q plus 1 into r plus 1 is 15, right? So there are multiple ways I can write it as. I can write it as 5 into 3 into 1, that is also 15. Or I can write it as 15 into 1, that is also 15. Okay. If this is the case, then your P is 4, Q is 2, R is 0. If this is the case, then your P is 14. Then your P is 14. So these are the two possibilities, only 15. You can break it at 5 into 3 into 1, 15 into 1 into 1. That's the only two possibilities. There is no other way you can break 15. So if P is 14 in the first place, so in this case, I can write n square as a to the power 4 b square, and r is 0, so c does not exist. And in this case, we can write it as n square as a to the power 14, right? If you know this, then it's easy. Then n will be a square b, and that gives you n cube as a to the power 6 b cube. And that gives you n as a to the power 7, and n cube is a to the power 21. So in this case, it will have 22 factors. And in this case, it will have, I'll do it here, n cube is a to the power 6 b square b cube. That means it will have 6 plus 1 into 3 plus 1, or 7 into 4, 28 factors, right? So it will either have 22 factors or it will have 28 factors. So now you can get the feeling of it, how to find out the number of factors. When number of factors are given, from there, how to derive. If that is not given, you can find out the number of factors, how you can go ahead and do it. So these are the two foundational problems that we solved. And please feel free to drop a comment if somewhere it's not clear or somewhere you are stuck in understanding. Okay, now if you see this carefully, you will see n square has 15 factors, right? N has how many factors? N is a to the power 7. So in this case, n has 8 factors, right? N will have 8 factors, right? So this is one way, right? Now, if you see, let's say, for example, 36. Now, if I take 36, what are the how many factors are there for 36? 36 can be written as 2 square into 3 square. So number of factor for 36 will be 2 plus 1 into 3 plus, sorry, 2 plus 1 into 2 plus 1. So that means 3 into 3, 9. So 36 will have 9 factors. And what are these factors of 36? 1, 2, 3, 4, 6, 9, 12, is that, sorry, 12, then 18, and then 36, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 factors of 36. So they have total 9 factors, and these are the all the 9 factors. Now if you see 36, 36 is a square of 6. So if 6 is a factor of 36, then there are, here I have 4 factors, here also I have 4 factors. So basically what I'm trying to say is 36 is a square of 6. Now there are 4 factors less than 6, 4 factors more than 6. So now you can understand, if it is a square number, then the number of which it is a square of, there will be equal number of factors less than that and equal number of factors more than that. Can I explain it into another problem? Yeah, for sure. Let's say there are, this is 100 is a higher one. Let's say 64. 64 is basically 2 to the power 6, right? Or 2 to the power 6, that means there are 7 factors. Now 64 is also 8 square. So what are the factors of 64? 64's factor 1, 2, 4, 8, 1, 2, 4, 8, and then you have 16, you have 32, and then you have 64. So 8 is also a factor of 64, and then there are 3 factors below, and then there are 3 factors higher than 8. So what we can derive from here is, if a perfect square has 2k plus 1 factor, have 2k plus 1 factor, or let it write it in a different way so that you can understand better. If n square has 2k plus 1 factor, if n square has 2k plus 1 factor, k factors will be less than n, and k factors will be more than n. So I hope it's understood. So if n square has 2k plus 1 factor, so in this case 36 is n square. So n is basically 6 here. N square has 2k plus 1. So if it is a squared number, you always know it will have odd number of factors. So from the previous example, previous concept that we have learned, so if it is as 2k plus 1 factors, which will always be true, then k factors will be less than n and k factors will be more than n. So like in the case of 36, we saw there are 9 factors. So 2k plus 1 is 9. So that means k is 4. So 4 factors are less than 6, which is n in this case, and 4 factors are more than 6, which is the 4 is basically k, and n is basically 6 here. So from the 36 example, you can understand that. Similarly, for 64, if n square is 64, my n is 8, and I have total 7 factors. So 2k plus 1 is 7. So my k is 3. So I can see 3 factors which are less than my n and 3 factors which are more than my n, which is 8. So this is a very important understanding, and you can actually solve a lot of problem. Okay, now let's take another example. Let's say if n square has 7 factors less than n cube has how many factors? N cube, how many factors? Okay. N square has 7 factors less than n. So I know n square, if I write n, we'll have 7 factor here, and then it will have 7 factor here. So can I say n square has 15 factors? So basically here they are saying k is equal to 7. So your 2k plus 1 is basically 15. So n square will have 15 factors. Now if n square is of 15 factors, n square has 15 factors. Now from here we can write that this can be written as 1 into 15, or it can be written as 3 into 5. That means we can say n square will either be a to the power 14. N square will either be a to the power 14. Like if it is 1 into 15, that means it can be written as so n square can be written as, okay, let me simplify this for you a bit. So n square written as a to the power p, b to the power q, c to the power r. Very similar, exactly similar to the problem we have solved few minutes before. In this case, p will be 14. In this case, p will be 14 and q will be 0. And r also will be 0, because 1 does not, the coefficient has to be 0 to contribute 1 in terms of the count of factors. In this case, p is 5 and q is 2. Sorry, p is 4 and q is 2. And r will be 0. So n square can either be a to the power 14 or a4 b square. Okay. Similarly, from here you can calculate n cube will either be a to the power 21 or a to the power 6 b cube. Very similar to the problem that we have solved some time back here. So if I go back, yeah, so this is the problem in 6b cube, and exactly similar we are doing here. So exact same problem. Now you can solve how many factors will n cube have. In one case it will be 22, in the other case it will be 28. Back to the rewind to the previous problem, and we'll be able to get the answer. Now with that, let's see, there is also another type of question that come in how many ways a number can be written as product of two numbers. So let's say 12. 12 can be written as 1 into 12, 2 into 6, 3 into 4. These are the three ways we can write 12 as a product of two numbers. Obviously, you can write 4 into 3, just considering 3 into 4 and 4 into 3 are kind of same. So now 12, how many factors 12 have? 12 is 2 square into 3. So 12 has 2 plus 1 into 1 plus 1. So 6 factors. 12 has 6 factors, and 12 can be written as a product of two numbers in 3 ways. So if n has x factors, n can be written as product of two numbers in x by 2 way when x is even, or x plus 1 by 2 way when x is odd. So this is another very, very important kind of a concept. So a number n can be written as total factors by 2 way is a product of two numbers when the total factor is even, or total factor plus 1 by 2 way when the total factor is odd. So for example, let's say 16. 16 is 4 square, or we can say 2 to the power 4. So there are 5 factors of 16. So 16 can be written as 5 plus 1 by 2, or 3 ways as a product of two numbers. So 16, if I see how we can write 16, 16 can be written only as 1 into 16, 2 into 8, and 4 into 4. These are the 3 ways you can write 16 as a product of two number. So 16 is has 5 factors. If the number of factor is odd, you just add it 1 to it and divide by 2. So this is also a very important concept that you need to understand. How many ways you can write a number as a product of two number? It's total factor by 2 if the total factor is even, total factor plus 1 whole divided by 2 if the total factor is odd. Now, before moving, there are another 2 formula. I'll say you don't need to see the derivation of the formula, and that's not much needed. There are actually 3, and I'll cover that. If n is equal to a to the if n is equal to a to the power p into b to the power q into c to the power r, then n can sum of factors of n can be written as a to the power p plus 1 minus 1 by a minus 1 into b to the power q plus 1 minus 1 by b minus 1, c to the power r plus 1 minus 1 by c minus 1. So this is the formula for the sum of the factors. Okay, this is the sum of the factors. Then there may be a question on product of the factors of n. Product of the factors of n is n to the power total factors by 2. N to the power total factors by 2. And how will you calculate the total factor? Total factor is p plus 1 into q plus 1 into r plus 1. So n to the power total factors by 2 is the product of the factors of n. And the last part, and this is more of a formula I want to remember, there's not much concept to be learned here. You should remember, should note this down and just go through before you go into an exam, so that these are on top of your mind always. And finally, the number of numbers which are less than n and co-prime to n. I'll explain what is co-prime. Co-prime of n is equal to n into 1 minus 1 by a, 1 minus 1 by b, 1 minus 1 by c. Sorry, my bad. 1 minus 1 by p, 1 minus 1 by q, 1 minus 1 by r. So these are the three things that you need to remember. So what are the co-prime numbers? The co-prime numbers are two numbers whose HCF is equal to 1. Okay. Now, what important thing to understand is the numbers may not be individually prime. So if I say 4 and 9, 4 and 9's HCF is 1. So 4 and 9 are co-prime. But 4 and 9 are not individually prime. None of them are actually prime. So number of numbers which are less than n and co-prime of n is basically one. This is the third formula that you need to remember. Before wrapping up factors, there is one more thing. Number of odd and even factors. So for example, let's say, again, taking an example of 12. So 12, we can write it as 2 square into 3. What are the factors of 12? 1, 2, 3, 4, 6, 12. So how many of these are even factors? 2 is an even factor, 4, 6, 12. So there are 4 even factors and 2 odd factors. So how to identify if something is given n equal to a to the power p, b to the power q, c to the power r, then how many are even and how many are odd factors? So I know so since a, b, c are all prime, apart from 2, all of them must be odd. I can say A, B, C are all prime numbers because this is a prime factorization. So apart from 2, all of them must be an odd number. Now, so I can simplify n as 2 to the power p, just taking this out, b to the power q, c to the power r. So if this is the case, then even factor will be p into q plus 1 into r plus 1. And odd factors will be q plus 1 into r plus 1. So this is another formula you can remember. So the number of even factors and the number of odd factors. So in this case, I can say my even factors are how much? Because 2, that is 2, because p is 2 here, p is 2 here, and 2 into 1 plus 1. So that is 2 into 2, 4. And the odd factor here is q plus 1 into r plus 1. So there is no r. So 1 plus 1 is 2. So that is what we got here. So you understood how to calculate the number of even factors and number of odd factors of a number. If you add these two, 4 and 2, you will get the 6 factors of that particular number. The factors of a number can be even or can be odd. So if you identify individually how many of them are even and how many of them are odd, by applying the formula that I just mentioned, you should be able to calculate the total number of factors. Okay. So these are the few things you should remember in terms of factors. It's a very, very important chapter, very, very important concept block in your number system. And that's why I wanted to dedicate one full session on factors. Before wrapping up, there is a small thing that you possibly use for division equation. So before going to division equation, if there is any open question on factor, anything that you are not able to understand or need a re-explanation, you can drop a comment or you can put a mail in the mail ID given in the description box and we'll be able to explain it much more better. We solved few problems, but we'll focus on a lot of problem on factor when we go deep dive onto problem solving. So for division equation, what we all know, if a number, so if there is a number, how to write the division equation for it? We know any number can be written as d into q plus r, where d is the divisor, q is the quotient, and r is the remainder, right? N is equal to d into q plus r. So that way you can write any number like this. This equation all of you know. I just wanted to touch upon a simple problem on this, and then we'll be able to wrap it up. Okay. So with this equation, we have new problem. I'll drop you a problem and you can try it at home. We'll solve that first in the next session and possibly going ahead further. Okay. Let's see. I'll give you a problem, try it at home, and we'll come back to the next session, solve this problem and continue. So a number when divides by a divisor leaves a remainder of 5, and when divides by thrice the same divisor leaves remainder as 25. Find the divisor and how many values it can take. How many values it can take. So I hope you understand the problem. It says a number when divides by a particular divisor. So a number, let's say n, divides by a particular divisor d, leaves a remainder of 5. The same number when divides by 3d or 3 times of the divisor leaves a remainder of 25. Try this problem at home. We'll try to solve this in the next session first, and then we'll move on. This is a thought and how we can apply the division equation. We'll solve that and move forward. So hope this session was helpful, and we'll see you in the next session. Till then, please drop a comment or a mail if you are stuck somewhere and need an explanation further, or like, share, subscribe the channel so that it motivates me to create such videos, which is completely free and helps you understand some of the important quant topics for CAT. Okay, thanks for listening in. See you next time. Thank you. Bye.